Hello everyone and welcome to this very first live for Virtual Performance Tool. We're going to be flying from Tango Foxtrot Romeo, Le Razet and Pointe-à-Pitre, to Tango November Charlie Mike, Saint Martin and Princess Juliana. The purpose of this first live is mainly to try it out, the format, try out the technical part, the views, the sound. So for those who are live with us, if you can advise me, if you can correctly hear me, if you can correctly see the video, is it smooth, and so on and so on. So the purpose of this today's live is really to make a two-short flight up and down, fly some standard Boeing procedures, use VPT as our performance tool, and yeah, have fun. So here we are at Le Razet, Pointe-à-Pitre. It's an island called Guadeloupe, for those who are not aware of it. And we'll be flying on board of the 737-800 from PMDG. A small disclaimer here, did a test flight earlier today and I had some technical issue with the plane. So we'll see if it happens or not, and we'll deal with it anyway. So can I just have some confirmation from the chats? Can you hear me properly? Oh, perfect, thanks. All right, so regarding the technical aspects, so it's a rather complex setup, I would say, for a very first live. But yeah, I want to make it a nice format, so bear with me as we try it. So the main view is the one you can see right here. It's the main gaming computer, and I can actually cycle through different types of view. We can have a look in the cockpit. We can have a look at different parts of the cockpit, overhead, aft overhead, FMC, pedestal, and so on and so on. I have added another view, which is quite nice for setting up the FMC with the charts. So I have included a webcam. iPad. So I have a physical iPad that is connected to the live stream, and you will see it right here. And I can actually move the view on my iPad. So we can go through different briefings, charts, OFP, and so on and so on. Then I have the main webcam that you've seen me earlier. And I can position it on the lower left corner or on the top right corner. I have another webcam located right behind me, which is right here. That gives you an overview of the setup right here. And finally, I have a mixed view here as well with the main computer. So during this live is not made to be a full tutorial of how to use the 737. I'll be using Boeing standard procedures. I myself am a former 737 NG pilot, and I fly now the 747-8 and shortly the 400 and different version. So yeah, I've stopped flying the 800 about a year ago, so it's a nice refresher for myself. So bear in mind, yeah, I can make some mistakes. I'm not that current anymore on this aircraft. If you have any question, feel free to write it down in the chat. If it's related to the current state, current phase of the flight, I'll be answering the question as soon as practical. If it's more general question about system, we'll try to find some free spaces, I would say, during the cruise. Although the cruise will be very, very short today. So I would suggest that we're going to move towards the next stage, which is the flight preparation. So we're going to have a look through the OFP. And then we're going to jump into the aircraft and do the full setup. So here we have the OFP that was generated by SimBrief earlier today. So the weather is not very accurate, I will say. We're going to update it with more recent information. So the flight we're going to perform, the flight number will be VPT-001, and it's scheduled to be today at 19:15 UTC time. The call sign will be VPT-001, and the registration of the aircraft is Oscar Oscar Victor Papa Tango. We are pretty light, as you can see here. We have only a zero fuel weight of 52.8 tons. It is light, and I will show you how the way I will handle the setup from SimBrief to the plane. I'm not using any extra tool or automatic import. I'll just guide you through it. All right. And of course, because of the very short flight, we have quite a low block fuel, and that means we have a quite low takeoff weight as well. The low zero fuel weight is mainly due to the fact I have set up SimBrief in the way that not all passengers will have a bag in the hold, which is closer to reality. Some passengers are traveling very light, and therefore I have reduced the bag weight to kind of simulate this, and this is why we have a quite low zero fuel weight. Anyway, on the way back in St. Maarten's, we're going to have some terrain and some performance limitations, so it's good to be on the light side. All right, so here we have a small technical issue with the SimBrief that generated me 5% contingency, where I asked him to comply with a minimum 5 minutes. It did it correctly for the way back, but not on the way to St. Maarten. So I'm expecting here to have 5 minutes, so I'll add myself a couple of kilos, so about 100 kilos for another 3 minutes. As you can see here, so it's pretty standard 37 minutes of flight. The alternate is Pointe-à-Pitre, so the alternate is quite funny. It's the same as our departure airport. So in case of something goes wrong, we have the fuel to actually return to our departure in case of diversion. So I'm looking through the chat here. Okay, and I'm not particularly talking to anyone here, so let's try to keep the chat clean for real questions. And so we have a block fuel of 4.5. Let's round it up to 4.6 for this contingency. And we have a reserve fuel of 2.5. The route is quite short. I will have a look on the map up there. There's a block times. As you can see here, the route is quite short. The top of climb is almost at the same point as the top of descent, so we'll have to anticipate that. And so here's some performance here made by SimBrief. Here for the departure is going to be all right. In St. Maarten, it's going to be way out of the real condition because SimBrief doesn't have the obstacles data. All right, so weather-wise, it's actually quite an easy day today. Le Razay has a pretty good weather. The wind picked up a bit, 150 at 11 knots. It was about 170 at 12. So everything is prone for the runway 12. Temperature is 31 degrees, so it's quite hot, so we have to think about it with the APU and the cooling and cooling down the cabin to avoid some sweaty passengers sitting in our brand new aircraft. And later on, we could expect some shower of rain and some TCUs, so that might be the case for the way back. We'll have a look with the updated weather. And at our destination, St. Maarten is beautiful weather. We expect some shower of rain, but that's for tomorrow. We have some other destination alternate, which are actually quite closer, like Tist. It's quite close to St. Maarten, so we can also have this one in mind. Regarding the NOTAMs, I had a pre-look before, so we have some daily closure, there's some work in progress. The work in progress supposedly to be reported by NOTAM, and which is actually not the case today. So there are no active work today at this airport. We will see that later on in the VPT that actually we have those work included. But like I said, they are not active by NOTAM today, so we're not going to use those NOTAMs. So based on all this information, the departure was good. And on the arrival in Princess Juliana, there's nothing much. Yeah, just the NDB that is out of service. In the NOTAM, there also something stated about some lack of ATC staff, but the hours where the shortage happens is again outside of the planned block times here, so we can disregard those NOTAM. So we're gonna use, if you're happy with it, 4.6 tons of fuel to make up for the contingency of 5 minutes and to run it up to the next upper 100 of kilos. So let's have a look here. We are in the aircraft. It's fully cold and dark. And the first thing we want to do, of course, is to power it up. I'm going to switch on the battery. I see there's no GPU. Okay, that is fine. So switch on the battery. All right, I thought I had a GPU. That's not an issue. We're gonna do some fire test and fire up the APU. Right, the test is passed. Let's check the extinguisher bottles. Loop 1 is good and loop 2 is good as well. So we can now fire up the APU. So while the APU is starting up, we can have a look on the updated weather. So the latest NOTAMs still wind from the south now. A bit of crosswind, 9 knots, variable, almost from a headwind to a bit of tailwind. So I have to take this into account. Temperature is still 31 degrees, QNH 1008, and it's beautiful Cavoquet. APU is now running, and let's switch in on the APU generators. It will take a bit of time, of course, for all the screens to light up. What we can actually do already is do the preliminary procedures. So we're going to actually have a look at all the safety equipment of the aircraft. We're going to start, we're going to find the life vest right here. We should have some fire gloves for each crew. This is the BCF. That's a fire extinguisher that replacing actually the halon we had previously, which is a quite toxic gas. We're gonna check all the circuit breakers. To do that, the best way to do it is actually to put yourself on the side and look them from the side. So any circuit breaker that will be popped out will have a white band on it, and it will be much more visible that way. We're going to check this P6 panel. We're going to check the emergency escape probe that it's correctly attached. And then we're going to jump into the aft overhead, and we're going to do the first tests. Take the airspeed warning, system 1 and 2, stall warning tests. Yeah, once you fire up the aircraft, it takes a bit of time. It sometimes doesn't work straight away. You have to give it a couple of minutes. So this is actually quite good. We're gonna try it later on. Sometimes, like in real life as well, you have to wait a bit, like for the system to wake up. This is the observer ACP. We don't have any jump seater today, so we're gonna just put it in flight. So to avoid any noises on the VHF-1, if for any reason the mic is activated, so just put it on flight. When I check the engine and the EEC, so that's basically the engine computers, they are on and not in alternate mode. And I check the crew oxygen, that's within limit. To know the exact limit, you have to refer to the FCOM, and it will be based on number of crew on board. So if you have 2 crew or a 3-member crew, the requirements will vary, and there's a table in the FCOM performance dispatch chapter. Passenger oxygen is correctly set to normal, and there's like a small wire that fixes it to close, as you can see here. Nicely modeled by PMDG. Light is off here. We have the 3 backup indicator for the landing gear. Service interphone. This one is not required here. What it does is actually activates all the jacks around the aircraft, where you can plug in your headset and communicate directly to the flight crew from quite a lot of parts of the aircraft. You have some jacks under the wing, at the refueler station, and so on and so on. So you have quite a lot of them. We usually don't use them unless, like, if one flight crew has to perform the refueling, then sometimes I used to switch it on so I can talk to the other member of the flight deck. In order for this one to be activated, you have this switch has to be on, and you have to listen on service, and of course talk on service, enable to communicate. So let's switch it off. This is the dome light. It's daytime, so it's not required. IRS display. We can actually put it to system, and we're gonna switch on the IRSs. On DC, that's normal. Then it will switch back to the AC power, and you have the align lights illuminated, meaning that they are in their alignment process. When you put the selector here to heading slash system, that will actually display the remaining time in minutes. And leading edge devices, you can actually check the leading edge position. This one, on the other hand, is much faster in the real aircraft, so it's a bit laggy on the PMDG. This one here, I don't know if you know, this allows you with some other screws here actually to unlock the whole overhead, and the whole overhead will fall down on the pedestal, so you can access all the wires behind. All right, let's move down to the forward overhead panel. So when I check from top to bottom, from left to right. Flight controls, and everything is closed, light illuminated. Those low pressure are normal and expected because of there's no hydraulic pressure at the moment. Those light as well, that's all normal. Yaw damper is actually available as soon as you switch on the IRSs. Give it a couple of seconds and it should be available. So let's see if it's correctly modeled. It is. Navigation, so everything should be set to normal, and the source to auto. Moving on to the fuel panel, you can have a look here. The fuel temperature, all the cross-feed valves are open. This is perfectly normal in this with the engine shut down. We can check the cross-feed valve. So it goes bright during the transition, blue when it's open. And let me just correct this. Yeah. And now it's fully closed. It could happen that the cross-feed valve breaks down, then you have like a circuit breaker that pops out. But sometimes it's hard to notice, and in the event you need to balance the fuel, like during the engine failure event, or if you have some imbalance, then your cross-feed valve is stuck in the closed or open position. In the open position, it could also lead to some other issue like fuel imbalance if some of the pumps provide a higher pressure than the other side. We're gonna have a fuel for in the main tanks only, so we'll just switch on the fuel pumps in the main 1 and 2. It takes a bit of time to build up the pressure, so this is perfectly modeled by PMDG. Over here we have all the electrical panel up here. This part is not really used. You can actually have a look. It's more for engineering. You can have a look here on the DC system. You can have a look here on the AC. So APU generator is the one providing the power, and we have the standard 115 volts and with 400 hertz. If you don't have the voltage, then the light will not be illuminated. So there's no really need to check it here. If the light is illuminated for the GPU or for the APU, that means that the current complies with the 115 volts and 400 hertz. So this is not really used here or in operation. It's more for engineering. Cabin TDI, Figali passenger seats, everything is on. Battery has been on. This is the drive. They are closed and connected. Standby power is set to auto. Drive lights are illuminated, which is normal because the engine is not running. And we're moving down to the electrical controller, where we can select the generators. Now everything is on the APU because we don't have the GPU available. This is the APU EGT. Wipers are set to park. Then you can set up the lights. The equipment cooling, that's more about for the E&E bay to cool down the equipment, is set to normal. Emergency lights to armed. We don't have the fuel yet, so we're going to leave the seat belts to off. We can we can check that the attend call is working. Moving out here, window heat. Let's put them on. It's a bit slow as well. Here, it's a bit slow to emit. It's much faster in the real life. Here we're gonna make sure that there are no person around that could be affected by the an abrupt build-up of pressure for the hydraulic system. Usually you have a pin in the nose if the tow bar is connected, so we just make sure that everything is safe, and then we can pressurize the hydraulic. Immediately the pressure is building up. You can see those lights are gone, and those two still require the IRS, I believe, to switch off. We have one door that is open. That is fine. The cockpit voice recorder here is not used. It's also for maintenance. And now we have the all this L, reverse L, is all about the air conditioning, pneumatic, and pressurization. So here we have the pressurization indicator. You have to make sure to check that the big arrow right here, there's actually two indicators at once. The big arrow is the differential pressure is set to 0, and the small arrow is the cabin altitude. It's set to your airport elevation, which is here close to 0, so it's perfectly aligned. That's good. And this is the rate of climb of the cabin. On the ground with the outflow valve fully open, it should just read 0. As voice recorder is set to on. I mentioned it was very hot. As you can see, it's like 40 degrees and more, so let's put some air. And we'll try to cool down the cabin a bit. All right, so now we have some duct pressure from the APU bleeds that provides a bit of pressure. Oh, sorry. And cruising altitude, that will be set right here for level 260. And we're going to leave the landing altitude at 0 feet. The precision select set to auto. So we have two controllers for the pressurization, the main one, the alternate one. And if the main one fails, it goes automatically to the alternate mode. And if the both controller fails, then you can try it in the manual mode and then control the outflow valve through the switch. Moving out to the external light, so we're gonna have landing taxi light off, engine start switches to off, the ignition to the right, and we're gonna alternate this at every flight. And it's daytime, so the position to steady is the only one required. There's no need really to put the wheel well or the wing or the logo light. All right, moving now down to the main panel. So I'm gonna start here on the side, put my flight directors on. I'll put some terrain, some airports, and I want to see some traffic, if it allows me. Now I think he's waiting for yeah, this is not fully correct. I should be able to select, even though there's nothing to be displayed, it should be able to activate the airport display. All right, we're gonna come back to it later. Maybe we can just help him out with the IRS position. And so gonna move to the next page, pick up GPS left. I like to cross check here, roughly here. Okay, that's very close. Let's see now if we have, yeah, we have the screen here, so that is good. And now airports will work. Yeah, although it should work without the alignment as well. The label here should be displayed, and once the alignment is complete, then you will see the airports. All right, moving now to the side. We're going to check the oxygen mask. And we're going to check the oxygen mask with 1% oxygen and with the emergency setting. Meanwhile, you have to check upstairs for the indicator not to drop more than 100 psi. Looks pretty stable. You need about 10 seconds. If there's no drop, then your oxygen pressure is, oxygen system is good. Of course, I forgot to mention, you will have, of course, check everything on the other side as well. Light vest. You will check the gloves, the fire gloves, and all the P18 panel here with all the circuit breakers. Moving on back here, you check the clock. It's 18:39 UTC, which is correct. You have to check it nowadays with all the spoofing and jammings. You may start with the wrong GPS signal from the start, so it's always nice to cross-check that we have the correct UTC and the correct time. Main panel, everything is set to normal. You can check the lights, make a lights test. So basically we check all the annunciator, and you start of course from all the way up and all the way down again, from top to bottom, left to right. You check everything. See here, those two are not illuminated. This is a mistake. It should be illuminated as well. There's only one lamp that is not illuminated during this test. Can you guess which one? Yeah, Christmas tree, exactly. So does anyone know which one is not illuminated during this test? I'll give it a few more seconds and okay, we have someone says yes, so let's see. All right, the only light that is not illuminated during this test is the wheel fire warning. This one is not checked during the test. It is checked when you check you do a fire test, but it is not checked during the light test. So of course we're gonna check all the annunciator from top to bottom, and I'm gonna select some auto brakes. Moving down, I'll set the parking brake. To set the parking brake, you have to apply the brakes and then pull it here. Red light is on, the parking brake are set. Checking quick here, the speed brake, flaps, levers, throttle, start lever to cut off, stop trim to normal. You have to redo a fire check for the wheel well. Moving down to the pedestal, I'm gonna do a fire test here for the cargo. I'm not gonna use too much. We're not connected to any live ATC, so I'm not gonna use the VHF1 that much. That will be for pilot monitoring, and there's no really point to spend a lot of time with some frequencies right here. Although I'll put something here for the VHF2, 1215. That's the ground frequency that we'll be monitoring all the time. And we can also preset some the ATIS frequency, which is actually not fully 1276. So yeah, let's try 1276. So 1276. It's on VHF2, that's where we don't hear anything. So I will configure the ACP. So both will be speaking on VHF1 to the main frequency. I want to listen to the VHF2. So now we can hear the ATIS. I will copy that later. I want to listen to flight. So this is all the intercom between the two pilots, or also with the ground staff. This is done through flight. And I'll put the speakers on, so when I don't have my headset, I can actually hear through the speakers. And the co-pilot will do exactly the same, VHF1, VHF2, flight, and most probably the speakers. Let's reset here the transponder to something like 2000. And this should be set to standby. I'll be flying, so I'll put everything on the left. So it'll take all the altitude source from the left. And as I'll be flying, I will be using command A, which will use the altimeters from the left side. So if we put everything to the left, this is what the ATC will see. And this is what we'll be flying. And the rest, it's all good. Could put some lights here. Trim is set to 0. Aeron trim, he's a bit hard to actually see it here, but it's centered. So the indication is actually right here on this tape. And finally, yeah, flight day door is not operative here. And those are the pins here for the landing gear. So we have to make sure that all the three are actually on board and not on the landing gear. Otherwise, we will not be able to retract the gear after takeoff. All right, as you can see now, the general setup is done. This will be a good time to do some checklists. So for the checklist, actually, I'm using the one from Boeing, which is quite short. I would say it's very straight to the point. I like it. And you can find it in any QRH. So if you take the QRH and open, I will try to show you here. So if you open up the QRH, you will find the index, again some indexes here, and you will find here the normal checklists, and so this is the one I'll be using right here. So I can already do the pre-flight checklist. So I will ask for my co-pilot to do the pre-flight checklist. So he will read an oxygen. That's going to be test 100%. Navigation transfer and display switches. That's all those here. Normal auto. Window heat on. Precision mode selector. That's this one, auto. And then flight instruments. So flight instruments, we have heading 056. Altimeters, yeah, this one is not correct yet, but it's okay. We're gonna check it for this one. For the standard, 160, 170, 056, and as well, the first officer will check it. 056, the altimeters, the reading, and we can cross-check with the compass here. Of course, you cannot cross-check the exact digit here, but it should be pointing towards 05 here. So I see 06, if you put it like in front, well, close to 05. So that's for instrument I checked. Parking brake, set, and engine start lever above cutoff. Pre-flight checklist completed. Now we'll have some time. I will do the FMC setup, and for that we'll need the OFP right here. So we're gonna start over in the ident page. It's a 737-800 with 26K, so that's the one we'll be using as well in VPT. So make sure we have the correct aircraft. The nav data is up to date 24/11. You can see the dates. We are between the two, so that's correct. This is the FMC version. So route from TFFR, flying to Tango November Charlie Mike. Call sign will be VPT 001. So departures Tango Fox Romeo, Tango November Charlie Mike, and call sign VPT 001. So this is all the first line. Now we're gonna put some departure. It's gonna be runway 12, and we expect the Bimba 2 Foxtrot departure. You can see it actually here through the route here. This route is a bit older, so it has the older departures, 1 Foxtrot, but that's when I use the new one, the 2 Foxtrots to Bimbo. Then we go to next page, and we're gonna add up the rest of the routes. El Lopo, and El Lopo, I will check here the arrival. Normally it's the VOR up Zulu for the Uluba 1 arrival. Via El Lopo. There's no other transition, so that should be correct. And it always does something weird here. Okay, it doesn't cut Uluba to all right, why? For some reason, the computer doesn't want to. Okay, he's happy that way. Although I have to check for the altitude here. By the way, I'm using the Jefferson app here, so I'm not using Navigraph. And let's have a look here. So that's the Uluba. And the VOR Zulu. That's correct. Uluba is 1600 feet here, as you can see. So we can actually leave it at 1600 feet right here. Good. Everything looks good here. So we can activate. And then this is the point where when this is complete, at some point we can do a route check. So let's just do it straight away. So this is of course based on the communication with the other member. So in my case, the co-pilot here. And we're gonna read through the OFP. So I have been entering the route, so I will read out and the co-pilot will check the routes. So in this case, I'm gonna just read out all the main information. So Tango Fox Fox Romeo to Tango November Charlie Mike, Victor Papa Tango 001, and then moving to the route, we have the Bimbo departure to Bimbo, direct to Elopo, and then the Uluba 1 arrival for a total distance of 180 nautical miles. 194, which is very close, so we can accept actually the route. Continuing here with the cost index at 80, the reserve fuel will be 2.5. Zero fuel weight. So let's now enter the zero fuel weight with the passenger. So in my opinion, I don't really care about the passenger, the cargo load. What interests me is the zero fuel weight. So what I usually do is just go to payload and I put 52.8 here. That gives some kind of distribution that is fine. That what matters to me is the zero fuel weight here, 52.8. That's what the OFP was calculated with. And it gives me a 24.3% CG. That's fine. Fuel wise, we say we're gonna go with 4.6. So now the aircraft is fully loaded, and we will wait for the load sheet to fill out the rest of the FMC. Meanwhile, we can actually have a look at the performance. So now this is a virtual performance tool. So that's the tool I have developed for Flight Simulator, and we're gonna have a look here. So I've loaded the PMDG 737-800 CFM56-7B26. So that's the one we have here with the steel brakes and runway 12. This is so as you can see here, there are other runway 12 available with some NOTAMs, but those are not applicable today as they are not mentioned in the NOTAMs. So I just use runway 12. If you have a look on the charts, let's go back here to the departure. So we are parked right here, and we're gonna use runway 12. As you can see, there's a turning pad right here. So we can actually select this one as a takeoff intersection instead of going all the way to the end. And so this is what we are going to do. That's the in pad. Try. And let's take the 80s and have a look at today's conditions. So let's have a look here. I want to listen to the 80s.
Airport information, Victor 18000 Zulu. Wind 195 at Niner. Visibility, tree. Sky condition, few clouds at 2,400 feet, few clouds at 4,800 feet. Temperature, tree 1. Dew point 10. QNH 29.77. ILS Yankee runway 12 in use. Landing and departing runway 12. TFFR aircraft
So as you can, I don't know if you heard properly because the sound is actually not coming straight from the computer. So I hope you were able to hear some of the 80s. So it's quite an old 80s. It's almost 1 hour old. And the wind is from the south, 190 at 5. So yeah, we're slowly picking up some tailwind. I mean, still, this is full cross, but if it's still variable as expected in the meter, we're more and more picking up some tailwind. There are a few clouds at two different altitude, 31 degrees, and the altimeters, it says 2977. So let's have a look here, 2977, reading about 20 feet. Makes sense. Now we compare all three of those altimeters. So I have a question here about from Sim to Heaven. Yeah, from the landing dispatch, actually, that's a good point. We'll be using it at this moment as well. So I will have a look here. Let me give you the iPads. So we can expect runway 10 with the predict winds. We can import the METAR. Probably flaps 40, it's quite short runway, and with the full reverse. And let's calculate that. So yeah, this is where you will be doing the landing dispatch calculations really prior to your takeoff. In larger or bigger companies, this is already done by by operations, so they will already give you some of those info. So you're less legally not required to do those check anymore if the company does in your OFP. As you can see here, we're not limited to 66.3 tons, and remember our landing weight is around 55 tons, so I have plenty of margin. So that's good. We can land at our destination airport. That's not a problem. All right, here. So I just pick up take off the info from the 80s. Oops, plus 190 at 5 knots. 31, and we said 2977. All right, and I want flaps 5. They won't have any improved climb, is not necessary. So let's calculate. And as you can see, I have not entered any takeoff weight, so this will actually calculate the maximum takeoff weight right here. So we are limited by obstacles, and we can take up to almost 76 tons. So with 7 or 8 tons takeoff weight, we are way within the limit. We can expect actually a 22K takeoff with quite a lot of assumed temperature. We can also do some calculation based on the estimate takeoff weight. So it's at 57 tons. So let's put it 57 here. And the CG was about 24%, but it's not really important at the moment. So let's just do with 57 tons. That gives us a flaps 5, 22K with 49 degrees. So this is what we can expect. Now we can actually do some briefing. Let's look at the time. Yeah, departure is expected to be in 13 minutes. So yeah, we better hurry up. I will try to make it on time. So let's do a quick briefing. There's plenty of ways of doing the briefing. The way I like it to do it, it's called our first state, who is the pilot flying. So I'll be the pilot flying. And then you check weather, no-time fuel, and state of the aircraft. Weather is good. We have some crosswind, but it's 5 knots, so it's normal operation. On few clouds, expect some TCUs later on, but we'll see if there's anything en route. I'll be having the weather radar on my side, and I'll have a look at it. No times we stated there's some ATC shortage, but outside of the block time for this live. So nothing major actually. And the same for the work and ATC shortage is ever not applicable to the flight today. Fuel wise, so we're expecting 4.6 with the corrected block fuel, so 4.5 round up to 4.6, so we can actually check that this is what we have here, 4.6 tons, and the aircraft status is good. So this is what we do when we get to the aircraft. We have the tech log, which is a big folder, and we go through all the latest pages. We see what's happened in the previous legs, if the previous crew reported any failures, and if so, has the engineer fixed them or deferred them for later on. So we're going to go through all the documentation. So for here, we assume the aircraft is perfectly serviceable. Then we start where we are here. So we are at the gate. Should be at the gate 8 or 9. Okay. We are at the gate 9 here. And now we're going to push back facing west. Then taxi, so it's the engine taxi on Romeo Foxtrot. Then we have the active runway. Once we're clear, we can enter the runway and backtrack the runway all the way to the sterner pad here. From there, we're going to take off. So it's going to be a flaps 5, 22K with about 40 degrees of assumed temperature. Going to verify this with the latest zero fuel weight. And then we proceed with the SID. So the SID is the Bimbo 2 Foxtrot. So this is located on the chart 10-3, effective from the 3rd of October. Airport elevation 35 feet. So that's basically what we have here. Transition to this 9,000 feet. So that is worth checking. And you can find it here in the transition to this 9,000 feet. Bimbo 2 Foxtrot, so okay, all category of aircraft are included. We are a category Charlie on the 737-800. And this SID requires a climb gradient of 9.2% until 400 feet. So that's a lot of gradient but for a short period of time. And 9.2% with the speeds of slightly below 150 would be about 200 to 1,200 feet per minute. So we should be fine up to 400 feet to maintain this kind of rate of climb. And then it's a 3.3%, which is standard SID. And again, the rate is quite low, so we'll be good for this requirement. Initial climb clearance, so Bimbo 2 Foxtrot is 5,000 feet, as you can see here. So this is the first line. Bimbo 2 Fox departure is initially 5,000 feet. And this is what we can actually preset here, 5,000 feet. So this is what will be clear too. And so initially it's going to be a track 116. I'll put the course as well. I'm not used to this anymore. There's no need to enter those courses on the 747. Well, that's good. So now we're gonna have a look again. I'll be briefing, and the first officer will be looking for the legs page and go step by step. So initial climb says climb on track 116. So that's what we have here, 116 to 800 feet. That's what we have. Then direct to Hadlow, still on the same track. And then Bimbo 2 Foxtrot. At Hadlow, we turn left direct to Nopal, So no pull, and then to bimbo. And that's the end of this departure. Well, MSA is quite high on the southbound and southwest, 6,500 feet, but anything else is standard. In case of engine failure, the procedure that has been calculated is the standard one, is climb straight ahead to MSA. So we just keep on the 116, we climb to MSA. So here we're gonna go above the sea, so I'm happy with 3,000 feet. We climb to 3,000 feet. And then we follow the checklist. So before 8 knots, I will reject for fire warning, predicted wind shear, aircraft unable and safe to fly. I will simply close the thrust levers, raise the speed brake lever, apply maximal manual braking, verify the position of RTO auto brakes, apply full reverse, stop the aircraft and set the parking brake. Before V1 the vehicle is continue, there will be no further action below 400 feet AGLs except to cancel any warning. Raise and landing gear was a positive rate of climb. At 400 feet, we're gonna identify the malfunction, complete memory item if required. And at 800 feet, we're gonna accelerate, retract the flaps, and climb to 3,000 feet, complete the QRH. We are very light, so there's no need to dump fuel, or not dumping the fuel, the 737, but burn any extra fuel. So once the QRH is complete, we can configure for a single engine landing and make a left circuit, so towards the north, whereas low MSA for a new approach on the ILS 1-2. All right, so this is good. Let's see, now we have the load sheets. So I'm just gonna pick up 52.8. Set it there, 57.4. Oh, I forgot entering stuff here actually. It's okay, it's gonna be fixed in a very shortly. There we go. 2, 3, 2. Okay, we'll see. And let's go now to the performance tool. We're gonna enter 57.4. 57.4. CG is 24.7. So all this is good. And one page. So we have a D rate of 22K and assumed temperature of 48 degrees. And that makes it 88.4. So it is spot on. Takeoff page, we're gonna go to next page. There you can actually add a few stuff. It's many crosswinds, so there's no need to put the wind. It's dry. Acceleration height 1,000 feet. We're gonna perform an NDP2. Reduction at 1,500 feet. Good. And engine out acceleration height. That's it's a height here, so yeah, indeed it's 800 feet. That is correct. My VPT is configured for the AMSL, and here it's a height, so it's AGL. So okay, this is correct. Previous page, flaps 5. CG 24.7. Let's make a trim of 5. This is what I have on in VPT as well. And speeds 130. Remember, VPT speeds always prevail. And VR 132. but within 1 knot you can accept. And V2 136, 137 is fine. I'm gonna put the MCP 137. All right, let's go here. So it should be, yeah, in 2 minutes. Aircraft is ready, so now I'll ask the copilot to ask for the ATC clearance. Let's assume it's provided, and we are going to fly the Bimbo 2 Foxtrot departure, initially 5,000 feet, and for the squawk, let's put something simple like 1,000. Now I have to, this is where I'm gonna lose a lot of time, is actually to coordinate everything. Ground service, notes, yeah, release, and then we're gonna go for the pushback. Meters. Nose goes left, and it's a bit. I'll try 120 degrees. There's a bit of an angle here. Why does? Okay, guys, sorry. There's not much else I can do. It doesn't really want to take the 120 degrees. Okay, before I hit start, let's do then, we're gonna request a push and start. So push and start is approved. And we're gonna do the before start checklist. I can quickly display here, before start checklist. Flight deck door is closed and locked. Fuel 4.6 tons, and we have 4 pumps on. Passenger sign, that's a good one. Windows locked. MCP V2 137, heading 116, altitude 5,000 feet. Takeoff speeds are, of course, takeoff speeds V1 130, VR 133, V2 137, that is good. Serial pre-flight is complete. Runner aileron trim 3 and 0. Taxi and takeoff briefing completed. And anti-collision lights set to on. All right, let's start.
We've been cleared for pushback and start. They want the tail to our right. Copy that, ready for push tail right. Release parking brake release.
All right, parking brake is released.
Brakes released.
Hello, Roy, who just joined the chat. Yeah, we're about to push back almost on time, 2 minutes late. It was always a bit a mess to jump from one menu to another to configure the push and all this kind of stuff. But we made it. And I'm gonna coordinate with the ground staff to start the engine, and the sequence will be 2 and 1. So I'm gonna put packs off. And starting engine number 2. N2. I have N1. All pressure is building up. Gonna start lever to idle. Gonna get some fuel flow, EGT, so we have ignition. And starter cut out, monitoring number 2, so we should have about 20%, and one about 400 TGT. It's a bit hot here, so it's a bit on the high side, which is fine. N2 around 60, that's good. Fuel flow is about 0.3, that's quite good. And the rest within limits. Alright, starting engine number 1. I'm going to also perform a supplementary procedure called isolated packs operation. As it's quite hot, we can close the isolation valve, set the packs to auto. Engine number 2 bleed is powering, feeding the right pack, and APU bleed is starting the engine number 1. Alright, so parking brake is set. Let's see here, N2 and 1. Fuel flow. So in real life, the guys will actually wait for the engine to be started, and then we're gonna clear them, and then he will go away and give the signal. Alright, starter cut out, and let's monitor the engine number 1. Save 3 checked. APU can go off. Probe heat to on, NTI is not required. And now set. I'm going already to set taxi lights on. It's a bit more convenient. So I'll put the flaps to 5. Just trim to 5, and flight control full left, center, full right, center, full down, center, full up, center, rudder, full left, center, full right, center. Oh, this is correct. Good. And before taxi checklist. So before generators are on probe heat, on anti-ice, off isolation valve, auto, engine style switches, continuous, recall, that's checked, auto brake, RTO, engine start lever, idle detent, flight controls checked, ground equipment, and clear on the left and clear on the right. Alright, then we request the taxi clearance. See, 20 degrees more, that will have been perfect. Alright, and let's assume we get the taxi clearance. and we're going to taxi all the way to holding point Foxtrot, which is quite a short taxi. So for any 90-degree turn, we're going to try to stay with a ground speed of 10 knots or less. I mean, the aircraft in real will not allow you to turn much faster. The nose wheel will really skid, and you will hear the noise and the vibration. So there's no really doubt or no way to go much faster in the turns. Alright, this is already Foxtrot. Let's do the before takeoff checklist. So let's see. Before takeoff checklist. Flaps. 5 green lights. Stabilizer trim. 5 unit sets. I stopped the aircraft because it's a bit hard to move the mouse and everything and keep going. I don't want to end up on the runway. So with the new update, okay, this is weird. I mean, there's not, we should not go above 40%, but come on, that is weird. So with the new PMDG updates, the engine spools up much slower, which is quite good, but it spools down a bit, I mean, way too slow in my opinion. It should spool down much faster than this. All right. Normally there's no traffic here, so we can let's try to find some nice view. All right, let's assume we are now clear to enter and backtrack the runway. Let's put the transponder, and I want the weather radar on my side. So the checklist has been completed. And let's go check, of course, that everything is clear on the left, clear on the approach side. What is really funny from jumping from the 7.4 to the 7.3 is like how small this plane is, like how big the runway feels, and how you feel the speed while taxiing. It's quite impressive. Like, you're so low to the ground on the 737 that you, I mean, really feel the speed. You're moving. You could be doing 50 knots on the 747. You'll be like feeling doing 5 to 10 knots on the 737. So the feeling is quite different. So remember, we are going Oh, there's a traffic landing there. Although as so we can already see the turn path over here. Let's assume that will be clear for takeoff. The 737 is also much easier to slow down. You have way less inertia than the 747. So when you're landing on the 747, you don't feel the speed, and it's quite hard to stop it. So it just goes basically. It just goes forward and forward. All right, I'll try to make this. Oh, I've one engine that went to reverse by mistake here. All right, let's see how it looks. Oh no, do not stop in the turn. Oh, jeez. Sometimes it's easier than to move forward and then initiate the turn again. Okay, not too bad. All right. Yeah. Oh, it's more like driving a bus versus a small car. It's really that huge. Well, I like it. It's really a fun aircraft. All right, here we go. I try to improve the settings for my yoke, because it felt a bit weird the last time I tried. Oh, it didn't go through this one. All right, let's go down. And one toga. Yeah, still a bit sensitive on the rudder. That's okay. So we have some crosswind. It's not checked. So we need a bit of cross control here.
V1, rotate. Positive rate climb.
Gear up. And one. Oh yeah, jeez, that's not very nice from my side. I haven't rechecked properly my MCP. So I've re-engaged now LNAV, VNAV. Flaps 1. Flaps up. It's still a bit sensitive, especially in the row. Or in the pitch as well. Okay. Yeah, it's very sensitive. 1000 feet to level off. Yeah, normally I will disconnect auto throttle, but I don't have a shortcut ready, so I'll just go FMC speed, VNAV alt, and here's a nice boy. He will do everything for me. I'll just level off. Usually we're gonna continue to straight, like direct climb. But I'm just gonna level off here, and then engage autopilot, and I'm gonna resume the climb. See, the Frederitus was not anticipating the exits. Alright, I'm happy enough. He will catch up from here. Command A. And let's climb again to, let's say, flight of 150. Has been set, and now we'll go to alt intervent, N1 VNAV speed. Alright, as well, we're gonna do the after takeoff checklist now. So if I give it to you right here. So it goes engine bleed on, PAX, auto, landing gear up, and let's see, off, flaps up, no lights. After takeoff checklist completed. Now we are approaching 9,000 feet, that's the transition altitude. So we can go at transition altitude. Set the standards, and we're passing flat level 9.5 now. Checked. And flat level 100. The start switch can be done, of course, with the after takeoff checklist, and we can release the passengers, let them use the restroom and everything. Alright, now we are accelerating. As you can see, top of climb, top of descent, they are all very close to each other. So we have to make a fast and efficient briefing. And now we're approaching 2,000 feet to level off, so I'll go to vertical speed, MCP speed, vertical speeds, putting down to 2,000 feet per minute. That's a nice way to not overshoot, and if you have any traffic around, to prevent any TCAS array. I'm gonna 50, 100 and slowly to 1000. And then we are clear to flight level 260. That is set, and I will re-engage VNAV and 1 VNAV speed. If you have any question about the FMA, just shoot them. Yeah, absolutely. So this is how it looks now. We have N1 is set together with the VNAV, so that's done automatically for the VNAV. And we have LNAV active. So if you go to vertical speed, of course then VNAV goes away, N1 goes away, now it controls the speed. You can reduce the rate of climb, rate of descent. So if the FMA will show MCP speed, which is 306, so it will maintain the thrust to keep the 306 knots. As you can see, the thrust is reducing to keep the speed. If I increase the speed now, the engine will go up. If I reduce the speed, the engine will go down. So this is what MCP speed means. So the target for the thrust is the MCP speed. LNAV is the horizontal navigation, so it's using the LNAV, the program route. If we go to heading select, that will obviously change to heading select. Oh, that's should always keep your heading back up. On the 7.4 you have a couple of few options to maintain your current heading, which is quite nice. But they were still within the range and stuff, so that's not a big issue. Back to LNAV. Let's see how it will react. That's a lot of bank. Let's see. Yeah, okay, it's not too bad so far. Okay, it's good. And then back to VNAV. Then everything has speed, window goes blank. Speed window goes blank because it's now FM. It's going to N1, so it's just going to N1 here, following the LNAV route and the pitching up and down for the VNAV speed. So the speed we have now the climb 306 knots, so he will pitch up and down to keep the speed. All right, let's now focus a bit on the arrival. Especially, it's not a very straightforward one. There's quite, I mean, the arrival itself is, the route is quite easy to follow, but there's a lot of transition and stuff, so it's better to take it early. So yeah, we're approaching for 260, and let's go already with the approach charts and the FMC. So I'll give the control to my co-pilot, and let's see here. Descents. It's going to be a very fast descent at 330 knots. In the forecast page, I can have a look here at the latest weather. 43 minutes old. Oh, the wind is slowly shifting to tailwinds. Yeah, that's a full tailwind, but it's 3 knots, okay. And we had some shower in the vicinity, 31 degrees, 1008. Regarding the wind is pretty much calm, so I will not put anything in there. I'm happy with this, the empty wind. So the information I put in here is actually will help to create a correct VNAV path, so vertical profile. So it will actually use the wind to correct the path and so on to make a full idle descent. Up to the FAF. So this is good. Why do we have? So we are going to fly the Uluba 1 arrival. That's on chart 10-2, effective from 3rd of January. So that's the star, and we're starting from Elopo. And it says on 305, I'm gonna intercept the 01096 to Uluba. So that's what we have here from Elopo, track 305. So that's correct, 305. And it says 2,600 feet and above. This is where it gets a bit confusing. Let me quickly check here. Oh, 1,600 feet, it's fine. So I'll just leave the autopilot doing the level off. I'm just gonna put 260 and above here. That is good. So then we proceed to Uluba, and we're going to join straight away the VOR Zulu runway 10. Approach straight in. Transition level 65, so that's the one we have here, 65. And then we switch to LS Zulu 10. And what's really matters is from Uluba, we proceed to Debir. That course is 096. FAF is at 1,600 feet. Then we start a descent. Down to the missed approach point. So I have Debir as the final approach point. Missed approach point for runway 10. Roughly 700 feet. Okay, understood. So we need the VOR. That's sick. We need the course. And the minimum, so the minimum, there's a restriction for the 500 feet that says that you have to keep a maximum speed of 205 knots until track 180, which is fine. However, there's no requirement here with the weather. The weather is quite good. Yeah, it's few 1800, so there's no need to make our life complicated, so I'll just go with the 770. And this is the MDA, stated by point 2. VNAV DA in lieu of MDA depends on operator policy, and that's for us going to be 770 feet plus 40 feet, so 810. And it says reset MCP altitude already. All right, let's start the descent. initially flight level 150. Yeah, I'm just making up some altitudes, and let's go. Yeah, start the descent now. Yeah, so minimum 810. And can NH was 10. .008. So now we are already started descent. Yeah, so it's about time to do some so we have 3 knots, so we go -3. Still 31, 1008. Flaps 40, and let's check the landing weight. Will be 55.7 -2, so 55.5. Five knots, that looks good. Full reverse, yes. And let's go here. We're going to put 55.5. It's going to be a flaps 40. VNAV disconnect. Why? What happened now? Why is it losing? Okay, VNAV path. Checked. So let's see here. We have auto brake 3 available and max. So as you can see on the taxi charts, there's a turning point here, but to make it we have to land with auto brake max, which is a bit too much on the brake and the temperature. Let's make us 25 minutes of cooling time, which is a bit much, I would say. Let's continue descent for the 120. So I'll go auto brake 3, and we're gonna go all the way to the end of the runway and make a 180 at the end. Now time is getting a bit critical, so we check the FMC. So again, the aircraft status is good. We have the fuel 2.9 and we need 2.5 for diversion, and so we're gonna have about 200 kilos of margin, so that's about 5 minutes. We cannot make a new approach unless we commit ourselves to St. Maarten, which is not always a smart move to make here, especially it's like single runway, and yeah, single runway. If something goes wrong, then we get screwed. But yeah, it's getting a bit high on profile. We have enough speed. Let's put some speed brake. Yeah, there's something weird going on here with the... What the hell is this? So for some reason the auto throttle disconnected, and then the thrust was full. MC speed alt acquired checked. Let's continue descent to 5,000 feet. Oh no, let's go. Level change 330 and we keep the speed brake extended. Come on. See, that's way too slow. Of the reduction of the thrust is way too slow. All right. Jeez. And speed 250. So yeah, this is what's happening here on the MCP. So now I'm trying to get the speed to 250. Well, but we are back on the path. So let's go back to VNAV path and I can close the speed brake. Yeah, it's a bit busy here. I missed approach, so track 180 climbing 4,000 feet. And we need to pass 2,600 feet within 10 DME. And then make a left turn back to the VOR and holds. Okay. Yeah, I should not have made all those demonstrations. Let's go. And BGM. Yes, BGM. Then as well. Okay, MSA. Yeah, so it's going to be 4,000 feet here for one. This sector, it's above the sea, so I don't know. And 2,600 there. Okay. Now let's get ready for some action because it's already a bit late. All right, let's go with the descent checklist. Descent check precision landing altitude is 0 feet. Recall been checked. Auto brake 3. Landing data VREF 40. Speed 129. Minimum barrel 810. Approach briefing. Yeah, I haven't done a real briefing exactly here, so let's just move quickly. So fuel wise is a bit tight, but we have the legal required fuel. One approach, and then we decide committed to Princess Juliana or we return back to our departure. Then approach, we're gonna fly this track, right turn, intercept. Then there's the FAF 1600 feet, 2 miles before. We're gonna set a lower altitude of 900 feet. And yeah, in case of missed approach, climb on the 180, 4,000 feet, and we have to pass 2,600 feet within the 10 miles, and then a right turn back to the VOR and hold. And we can maybe expect vectors or something like that. So flaps 40, vacate, make 180 at the end, backtrack, vacate Charlie, and then we'll see the stand. We're gonna pick up a stand somewhere over there. Yeah, Sky Check, I don't know when you send the message, but good evening to you. All right, it was a bit busy, but we made it. That's the island of Saba over there. and that's St. Maarten. You can see the runway over there. Oh yeah, approaching the transition, so 1008. And check, continue descent to 2,600 feet. So 1008, passing 5,200 feet now, checked, and then we go with the approach checklist, altimeters 1008. I already set this one, so it's more convenient. Let's go speed intervent and start reducing FMC speed. So this is where I have some issue here. The plane goes a bit crazy on final approach. Like it goes into a go-around mode by himself and stalls, and yeah, very interesting. So I went into speed intervent mode, as you can see here. So we're doing the approach in LNAV, VNAV. So not in VOR mode, although it's a VOR approach, because the LNAV is more precise. And in case you do a localizer approach, flaps 1, then you can actually use the VOR lock, because localizer is more precise than the LNAV. Check, check. Next will be 1600. So that's been set, 1600 feet. Flaps 5. Oh, come on. Sometimes the engine behaves like a sport car. Let's go flaps 10. I just want to be configured a bit early because of the issue I was having, so I'm trying even to disconnect the autopilot, and let's hope that this time it works. Now we're about 2 miles before the FAF, so now we can actually set the lower altitude. So we're going to put 900 feet. We have VNAV path And let's go with the gear down. Like I said, I want to be configured a bit early here, especially that it's doing some weird stuff. And it was started to do some weird stuff with flaps 40, so I'm not sure if it's related or not. Checked. Go flaps 25. So this is the FAF. See? And again, here we go again. See, nothing was actually wrong here, but see, I'm not crazy, huh? But now it's impossible to recover the speed, which is weird because the thrust should be on idle here and it's at 30. Yeah, that's okay. Flight directors goes off, that's fine. But airspeed is not low, and this is happening all the time here. So I have no clue what happened and why the airspeed is suddenly low, where it is actually in flaps 40. Come on, why is it not 40? I mean, in real life, of course, I'll go around, but there's no point here to go around because it just happens all the time. And okay, flaps 40 due to the but I should not be able to maintain this kind of speed with manual braking. Yeah. Yeah, thanks. But I don't know if you see what happened. The aircraft went into a stall. Come on. And on top of that, it's impossible to slow down with no thrust, fully configured, gear down, 700 feet per minute. I should be losing my speed. So if you've seen this before, yeah, okay. Because I have no clue why this is happening. Oh, we'll see on the way back if it does happen on the ILS approach, or is it something really related? And the brake temperature goes way too high, and I was with full reverse auto brake 3 until like 80, 70 knots, so should not warm up like this. All right, so here we are in Saint Martin. So now we are taxiing. Here we have Echo, Delta, and we're going to take Charlie. All right, we clear the runway. Ah, I hate what they did here with this. The mapping of the switch is terrible here. I always have to try 10 times before finding the correct position of the switch. Okay, like this it works better. And let's start the APU. Oh, come on. So I'm taxiing towards Bravo 1, which should be the next one here to the right. Over here. That's much too fast to enter the gate. And this guy is useless. I think this should be fine. Let's have a look. Yeah, happy with that. Parking brake is set. Let's have a look with the APU. APU is available. And we are ready for shutdown. Will be a good, oh yeah, this one as well. Much easier when you have a first officer doing the job. All right, and we have what? About 20%. Anti-collision light goes off. Let's go here. Check, check, check. Start switch. Oh, this one as well goes to auto. Looks about right. Then we do another shutdown checklist. Because fuel pumps may stay on probe heat off, hydraulic panel is set, so leave the pumps on, flaps are up, parking brake is set. Once we get the chokes I will release for the cooling, engine start levers are cut off, and weather radar is off. Ashdown checklist is completed. Welcome to St. Maarten. Alright guys, if you have any questions, feel free to shoot. Meanwhile, I will open the required document for like the OFP for the next flight. Oh, I haven't imported it. Okay, that's... Alright, let's go now. So the departure time, I think we are pretty much on time, I think. Let me check the blocks. Block in 20, yeah, 5 minutes ahead. Departure time now is set at 20:45, so that's in 30 minutes. So we have to be pretty quick here as well. Let's pretend that we have some passengers. There's no need for GPU as we need some air for the hot temperature. All right. Well, I see there's no question there. So if you are happy, we're gonna set up the return flight. This one will be a bit more tricky as we have the terrain, the obstacles, and for the in the runway access. So we have to think about it, take this into consideration. And this is where VPT is a very handy tool. And guess what? Call sign is VPT002. Let's put runway 10, and the route here is Modor to departure. And then to Spata. Check. No, I think I was a bit fast on the activation. Oh, it's okay. Spata, then Bimbo. And Bimbo is already the arrival. Oh, totally forgot to share with you. That will be Snow 16. Let's execute that one. 1-4, yeah, makes sense. Sorry. Arrival. It was reported ILS Yankee on the 80s, so let's go with the ILS Yankee. Let's have a look if there's a big change. No, as usual is the high, yeah. It's not gonna be the Zulua. It's gonna be a straight in, wherever the So it's not going to be the Yankee. He's going to be a straight in through the Zulu via Desto. We're not going to fly to Pointe-à-Pitre VOR and then go outbound, TME arc and inbound. No, that's not going to happen. This is not going to happen. So it's going to be something like this. Desto. And a Zulu. Desto. And which arrival then? 1, 2. Bimbo. Okay, which one now? Offset. What? Reading. What the hell? How do I connect here? Number 3. Oh, number 3 is Saxo. So maybe I made a mistake here. No, reading. Saxo. That's number 3. That's for the Bozet 2 Zulu arrival, so that's not the applicable. Reading, yeah, that's possible. Reading. Reading is here. So let's go reading and then the Bimbo 2 Zulu. That should be fine. Oh, looks happy. And then we have track 116 all the way. Another one, yeah, looks good. We made it. All right, cost index 80. Reserve is. See, here we have minimum 5 minutes, so that's correct. 4.3. Let's take 4.4 for the APU. Sorry, 4.4, that's the fuel I want, and the reserve is 2.3. Leave this out. Flight 190, wind 3394. Temperature plus 17. All right, this is. I'm happy with this. Cruise and descent. Good. Now this is where the performance part kicks in. So we have a takeoff weight of 57 tons. And one zero. So see, this is the engine failure procedure below. So we're gonna have a look at this. Full length, yes. Dry. Wind is still variable with like 3 knots. All right, and still 10. Let's refresh it. Now still 1008. Now we're gonna leave the flaps to optimum. Let's see if we can do some improved climb. Now let's have a look here what we can do just for flaps 5. So let's say if we don't do anything special, we're limited to 56.7. So we're missing 300 kilograms to be able to take off. Let's go now flaps optimum. Should give us like flaps 1 to get a better climb. Flaps 1, 57. So now we are slowly, I mean, we are within limits. That's really on the edge with full 26K. The runway is quite short, so I don't think the improved climb will give a lot of options here. Just like 100 kilos more, which is fine. One thing we can also consider is going with the packs off, so no engine bleed. Sorry, so actually technique is no engine bleed takeoff. The packs will be somehow on with the APU bleed, and that gives us 1.2 tons more. But that's okay. We're gonna just use. We are still within limits with the standard configuration. We have tailwinds. If the tailwind picks up, then we have to go with the no engine bleed takeoff. So we have what, 50? Yeah, we'll have to. All right, let's. I'll just request the payload and the fuel. I mean, while I'm still there, and then we're gonna go for the engine failure procedure. 53. Next 24.4 and fuel. We said 4.3, 4.4. Oops. Once the full number. Running graphic on VPT. Yeah, okay, here. I guess you mean this one. Yeah, I need a weight. So it's gonna be 57. So it's gonna go for the 26K. And probably full. Yeah. See, there's no assumed temperature. Full 26, 57 tons, limited by obstacles and flaps 1. Okay, so the graphic here, so it displays the distances. So you have 3 distances displayed. So you have the all engine go distance, which stands what's just like I said, it's the distance, the takeoff distance with all your engine. You have to be careful here because it includes a 15% margin. So that's why sometimes the green line is longer with the than the purple one. You say, yeah, but how is it possible that the all engine go distance is longer than the one engine out go distance? It's just because of the 15% margin, so 15% margin. Then you have the EO go, which is engine out go distance. So if you lose an engine, that's the distance you will need for the takeoff. And accelerator stop distance is the distance where you will need to reach V1, then reject the takeoff and stop on the runway. So I hope this clarifies the graphic here. And you can see different type of margins information here. Slope margin, you have some of the clearway, stop way when there is one. All right, so it's gonna be quite tight. Now let's have a look at the engine failure procedure. It says climb straight ahead to DME 1.2. So let's start with the Papa Juliet Mike. And 1.2, which is very short. It's the DME is located, I believe this is the DME, VR DME. And 1.2 miles, and this is the terrain we have to clear in case of engine failure. So I believe if we're gonna have a right turn If I have a look here, make a right turn, 15 degrees of bank to track 150, and I believe we're gonna try to get this in between those two mountains in case of engine failure. Remember, this is a procedure that is made to be flown in IMC as well, so without visual contact with the ground. So it's very important to understand and comply with the procedure. So let's zoom in. Let's zoom in here. So see, that's really at the end of the runway, 1.2. So it says Papa Juliet Mike. Uh, 1.2 DME from the VOR, make a right turn with 15 degrees of bank. Track 150, so we can actually put 150 slash, which will give us a track. You can have it look here. Let's center the map. So you have your 1.2 DME circle and the track. So at the end of the 1.2 here, at the end of the runway, make a right turn with 15 degrees of bank to be parallel to this track. So we're gonna fly towards that direction. So that will be roughly between the two mountains. Then that's it. So it's track 150, max speed 150 knots, all turns. So we're gonna keep the V2. I'm not gonna accelerate. I'm not gonna retract the flaps. I'm gonna keep everything under control until we are on the track 150. Once we are on the track 150, then we can actually accelerate. Let's actually enter more information as well, because part of the departure here, we can also expect a different engine out acceleration height. If you get a look here, it says 1022 feet IMSL, so 22 feet, that's roughly the elevation. So just put a 1000 feet above ground here. And we're gonna no, I think I'm gonna change that. There's no thing stated here about the noise procedure. Oh, here. That's VFR. Show remaining runway access up to 2000 feet, then climb to, when climbing, and 3.5 DME from. Oh, sorry, that's the wrong airport. Overview. No. So there's nothing stated here, so we can do whatever we want. I will change to an NDP1, so we get high enough away from the terrain, and then we can accelerate and retract the flaps. Reduction can happen at 1500 feet. That's not a problem. So is it clear what we'll be supposed to do in case of engine failure? Amazing. I'm just trying to finish quickly the preparation. It's even a bit higher, so this 300 feet. Okay, that is all good. This has been covered. 096, yeah, okay, that's fine. We don't know which altitude, so I'm just gonna put something like this. 96. Oh yeah, missing the takeoff weight, that's why. That's why VNAV doesn't engage. Okay. So again, let's start with a briefing. So I'll read about flying. Weather is still good. From our latest report, it's all still very good. There's some shower in the vicinity, but so far this TNCM looks good. We will NOTAM-wise, there's nothing special for the departure. There's the engine failure procedure, which is quite complex. I mean, it's not too complex, but you know what I mean. It's not a standard one, and we have to be quite prompt in the actions. We cannot let the starter effect take too long. We have to act accordingly. Fuel-wise, so we need 4.3. We have 4.4 on board. That took 100 kilos extra for the APU. NOTAMs, like I say, weather is good. Fuel, aircraft status is good. Let's check just the brake temperature. They are reducing, but still quite high. Why is it not switching to the arm? Just gonna cool the brakes. Yeah, with all the issue we had during this approach and braking wise, yeah, it was a bit weird. The temperature picked up way too quickly, so yeah. All right, then we are Bravo 1, pushback facing west, short taxi, Alpha. The thread here is that the holding point Alpha is quite far away from the runway, so we have to stop actually right here. And then once clear, we can line up. I'm going to use the full length, full power, flaps 1, take off. Yeah, so full thrust, flaps 1. And let's now check the departure, which was the... Oh, already forgot. The Modor departure. So Modor, and then we go to Sparta. Yeah. All right, chart 10-3 Bravo, effective on 3rd of January. Port elevation is 14,000 feet. Transition to this 5,000 feet. Only 5,000 feet is set. Initial climb and routing instruction may be superseded by radar vectors as soon as practicable. Turn right. Okay, so basically we should be able to climb the 400 feet, then make a right turn, get away from the terrain, and we fly the Modo and Sparta. Okay. Climb direct to Modor, close Modor at 4,000 feet. Let's change the view again. So 420, that makes sense, 400 feet above ground, that's where I was talking about. And then make a right turn, Modor, and then Modor we have to cross 4,000 feet and above. See, that's why I don't want to accelerate too soon either. Just want to climb as soon as possible and make this turn. Cross Modor 4,000, and if enable, advise ETC, we should be fine. Turn left, direct Sparta. Looks good. The SID requires a minimum ceiling of 1,200 feet, which is fine. We have a few and like 1,800 feet, so that's good. And 2.8 nautical miles of visibility, so that's not an issue today. Closing obstacles, that's going to be taken into account with VPT. And I have 10. Okay, that's just information wise. MSA again 2,600 in the east side and 4,100 in the southwest. Again, so we're gonna climb in case of engine failure. We're gonna climb to 1.2, so basically end of the runway. Right turn, heading 15, track 150. So corrected for the wind. Wind is coming from the south and a bit of from the west. So most probably like heading 155, something in between, 150, 155. To keep this track 150, and we climb to 3,000 feet. Once we're at 3,000 feet, we can pick up a halt anywhere and perform the QRH. The distance it's quite short. I think I would rather fly on the single engine towards the destination. It has a way longer runway to land with flaps 15, so I would definitely fly to the destination. It's only 200 nautical miles away, so that is fine. It's within the legal limit. All right. So that's it. Again, the action. Above 8 knots, I will only reject the fire warning here. Predict which aircraft enable safe to fly. I will simultaneously cross the thrust lever, disengage auto throttle, manually raise the speed brake lever, apply the brakes, or verify the operation of the RTO auto brake. Manually raise the speed brake. Manually raise. Jeez. I will apply full reverse, stop the aircraft, set the parking brake, and we will advise ATC of the reject. If you continue, no further action below 1 feet AG up, cancel warning, raise then they give us a positive rate of climb, 15 degrees of bank, 1.2 DME, high turn, track 150, no acceleration, we keep the V2 speed, 1 son of 150, then we proceed acceleration, which is about 1,000 feet above the ground. Then we accelerate, recheck the flaps, and proceed to 4,000 feet. Way below maximum landing weight, so we can. We're not, like I said, we're not gonna return here in case of engine failure. But yeah, quite light anyway. Yeah, I think briefing is pretty much covered. Let's have a look here. Just waiting for the weights. Let's assume that we have the weight now. 57.4. Ooh, that's a bit more. Can we accept 57.4? We're gonna burn some fuel, but that's no more than 200 kilos. Geez, 57. Let's go 2. Okay. 50. Oh. Why is it 57.2? That works. 57.2. Yeah, I don't know, for some reason it disappears. This is quite a interesting bug. 57.1. Let's try something like this to see. It says we can go 57.2, so I'm gonna burn 200 kilos with the startup, APU, taxi. Okay, that works. So anyway, it's gonna be full thrust. And 1 full takeoff thrust, 103, 101, See, maybe temperature is a bit different. 30 degrees, I have 31. That's why we have the difference in N1. Okay, let's continue. Flaps 1 with the CG. Ah, about 24.7. And this one was a bit different as well. As you can see, it's not as simple as it seems, so you really have to play with the limit. Yeah, 1000 feet still, that's good. And trim 4.4, 4.5, okay, that's good. Speed 135. One 146 or 145, that's fine. 57.4, it's gonna be 57.2 checked. All right. And the MCP 145 VNAV. Let's go again with the pre-flight checklist. Oxygen is 10%. Navigation to display switches normal auto. Representation mode selector auto. Flight instrument again. So I have 005, 005. Altitude 1008, about 20 feet. 1008, well, roughly like 20, 25 feet. Parking brake is set. Engine start levers. Good off. Pre-flight check is complete. And let's now close the doors. See, this is where I lose a lot of time in the sim. Alright, push back, stand L left, yes. Yes. I'm gonna put it a bit further away. We'll see. So let's have a look here. We have the fuel. APU is running. Check, check. Yeah, we're ready. Again, we're gonna request the clearance to the tower. Let's assume it's gonna be 6,000 feet. I'll put 6,000 feet here. The departure with the Squawk 1000. It's good. And let's go now then for the start.
Cockpit to ground. Go ahead. We've been cleared for push and start. Tail to the right. Copy that. We're gonna push. Tail to the right. Parking brakes release, please.
Alright, and quickly before start, checklist. Flight deck door is closed and locked. Fuel, I have 4 pumps and reading 4.4 tons. Passenger sign is on. Window locked. MCP 145096, altitude 6,000 feet. And let's recycle the auto throttle. Takeoff speeds. I will release.
Brakes released.
So I'm tired of this system. V speed 135, 135, 145. City pre-flight complete. Rudder and aileron trims. That's
Here we go.
here 3 and 0. Taxi and takeoff briefing completed. Anti-collision light, it's here. It's on. Before start checklist completed. Yeah, again, now with all this procedure, I have 3 minutes delay. Scheduled 45. And let's start the engines. So the sequence will be 2 and 1. Starting engine number 2. And 2, oil pressure, and 1. Fuel flow, EGT. And start the cutouts. Number 2 is stable. Starting engine number 1. Oh, I forgot to cycle to the left side. Right. And 2 and 1 oil press. Parking brake is set.
Alright, steering pin is disconnected. Watch for a slip release from that side or left. Have a good flight.
Check. Start cutouts. And number 1 is stable. And here we go again. NTI is not required. Ah, that's... Jeez. And 4.5. It's funny how those kind of things you forget to do when you're not used anymore to the 7.3. All right, so now flight controls. Full left, center, full right, center, full down, center, full up, center. Mirror the rudder, full left, center, full right, center. All right, let's go now with the P4 taxi checklist. So let's go. Okay. Generators on, probe heat on, anti-ice off, isolation valve auto, engine start switches continuous. Now recall checked, auto brake, RTO, engine start lever. Idle detents, flight controls checked, ground equipment clear, and forgot that. Taxi lights, request taxi, And we are clear to taxi to the holding point Alpha. Let's see here. Oh, yeah. Yeah, nice catch. This is where the checklist is for the before takeoff. But yeah, you're right. Flaps. This the threat of flaps 1 takeoff is it's not the usual configuration. So yeah, it's easy to forget. Well then, yeah, let's go with the before takeoff checklist. So yeah, flaps at 1. Nice catch. Now we decided to keep the packs, no, the bleed, the engine bleed on, so that was still within limit. If we would have needed more, like a higher takeoff weight, then yeah, we should have taken the packs off. But we did the calculation with the packs in auto. And here we are already at holding point Alpha. So we said before takeoff checklist flaps 1. Stabilizer trim was at 4.5 units. Let me. Yeah, 4.5 units. Before takeoff checklist completed. Quick review. Case of engine failure. Straight ahead, end of the runway, 1.2 DME. Make a high turn, track 150. Maximum speed 150 knots. Yeah, I'm climbing to 4,000 feet. Otherwise, the departure itself, we climb 400 feet as soon as possible, 400 feet, right turn, and we proceed direct to Modor. Ah, yeah, absolutely. It's getting a bit dark here, so I'm gonna put some light before it gets too dark. And let's say we are clear for takeoff. Alright, there we go. So speeds, everything is in. Flaps 1. And 1, set takeoff thrust. Thrust is set.
8 knots.
Checked. Oh, it's a bit too much.
Rotate. Positive rate of climb.
Gear up. And now VNAV speed. That's a bit. I was a bit slow on the rotation, as you can see. Then the speed up picked up quite a lot, especially because we are super light. Now I'm trying to rejoin the departure. Flaps up. And let's see, we can climb now to flight level 120. That 120 is set. Transition altitude. So set standards. Passing flight level 5.6 now. Alright, looking good. Command A. And after takeoff checklist. Engine bleeds on. Pax auto. Landing gear is up and off. Flaps up, no lights. After takeoff checklist complete. It's getting dark fast, huh? See, now we are accelerating. There's one thing that will happen here. That as soon as we're gonna get the speed, the vertical speed will increase very rapidly, and the level off is at 120. So it's really good to anticipate that and go to vertical speed. See how it goes high. Vertical speed 1000 feet per minute. MCP speed, vertical speed. And now let's say we are clear to 190, that's the final set, and we are going to set to VNAV. And 1 VNAV speed. And here we go, 100. Alright, here we go again. Now we have to prepare the next approach. I will already start doing some configure the MCP, so this is set. Frequencies for the ILS 110.3. The VOR over there is 112.9. And finally, the minimum will be 255. We're going to go vertical speed. And 1000 feet per minute. Checked. MCP speed, vertical speed. Well, I hope the aircraft will fly fine this for this approach. And I'll acquire I'll hold FMC speed VNAV path. Alright, there's no time here to rest. Do it very promptly, so let's go here. Descent again, we're gonna be fine here. I can check latest weather. 7 minutes old. Let's share with you the info here. So the weather is quite okay. Still has a bit of crosswinds and moving towards the tailwind side as well. Otherwise 30 degrees, 1008. As you check the transition level, it says by ATC, and it was like 9,000 feet for the transition altitude. So yeah, 100 makes sense. We're gonna leave it like this. Yeah, 9,000 feet off. 100 for the transition is quite reasonable. And then let's go. Here, fuel-wise, 3.2 tons currently. We expect it to land with 3.2, and the OFP says we need 2.3. Oh, sorry, 2.8. 2.8 landing with 2.8, 2.3, so that's 500. Okay, we have about 10 minutes. So it's a bit tight for an approach, but a very short approach, we could do it. And in case of, depending on the situation, then we can always commit to the airport if required. Otherwise, the alternate is Fort-de-France, which is like the island, one or two islands south. It's two islands, also a bit further down here. TFFF. So second island to the south. NOTAM, I've already discussed that. There's nothing major. Aircraft is fine. Weather is good. A bit of tailwind, but that's it. Then routing wise, let's go here with the legs page. So it starts at Bimbo. 189. We fly to number 3 is. Oh yeah, for this one to read in straight away. 3,600 feet and above at read in, good. If clear for the approach, see charts, ILS Zulu 12, that's the 1. And then from read in, so if not clear, we have a holding here. And then 116, we proceed on the ILS, India Romeo 12 Zulu, 3,600 and above. And then we have a 10 DME, that's be this point, Fox 12, 3,600 feet exactly, that's the final approach point. And then it's a bit steeper approach, it's a 3.2 degrees, so it's a bit steeper than usual. Then to runway 12. We discussed the course and so I have course 116, frequencies 110.3, and minimum was set to 255 ILS category Charlie. In case of missed approach, climb straight ahead to Fox Romeo 510. 510 is set. Then make a left turn direct to Fox Romeo 512, and then left again to Desto. Climb to 3,600 feet, maximum 240 knots. Climb to 900 feet prior to level acceleration. Okay, that's understood. So it's basically a left, or fully airnav missed approach. I'm gonna have a look here on the performance. So let's reset MCP altitude. Yeah, let's start the descent down to for the 120. And pressing here the alt intervent switch here. Retard enough speed, so we're starting a gentle descent. Oh, we're already above the path. That's why it's a bit crazy. Okay, speed brake. Yeah, it's only 1,000 feet high, so it's okay. What I was talking about, yeah, landing en route. Try and 30, QNH is still 1008. With the tailwinds, yeah, maybe flaps. It's okay. Actually, flaps 30 should be fine. And landing weight. So we still have 200 kilos to burn. 55.8. VNAV path. So slowly storing the speed brake. Flaps 30. Why? Why is it disconnecting the VNAV for no good reason? VNAV path. Check. FMC speed VNAV alt. Okay, that makes sense. Approaching 120. So let's descend now to find out. Eight zero. Alt into vent. Retard VNAV path. Still a bit aggressive, in my opinion. So let's have a look here. Yeah, this is exactly what I wanted to see. I want to vacate via echo. So auto brake 3 is good. We'll even have to disconnect a bit. Auto brake 3. Auto brake 2 is a bit tight, even if you remove the margin and stuff. But auto brake 3 is good. And we're gonna take echo. Echo to the left, and we're gonna park in the terminal. Probably stand 8. Drag required, no. Alright, that will be the, we covered everything, performance done. Alright, let's go with the descent checklist. Precision length is 300 feet. Set. Recall. Checked. Auto brake 3. Landing data VRF 30. 137. Minimum barrel 255. Approach briefing completed. Oh yeah, passengers seated. That's good. Approaching for the 100. Oh, I can. It's still a bit early, but let's put the logo light. So as you can see, the arrival is pretty easy. We just have a one left turn, and then we'll be in the axis. And the 3.2% glide is really due to the terrain in front. Resetting the altimeters 108, passing now on 8,900 feet, checked. Right, reaching out 8,000 feet. Let's continue the descent. Let's put 5,000. And let's even get 3,600 feet. We are clear for the approach. 3,600 feet sets are VNAV path. ILS Papa is identified. and flaps 1. Approach checklist 1008 checked. Vol lock captured. Approach armed. Flaps 5. So speed into vent, so I can control my speed. I was a bit too conservative on the configuration, but okay, that's gonna be just be a bit more sightseeing. Glide slope captured. Missed approach to 3,600 feet set. Yeah, the views are amazing indeed. And flaps 30. Meanwhile, let's complete the checklist. So we've been so busy with the view. Why is it going flaps 40? That's not what I asked. But still in the amber band, this is not correct. Huh? There's some issue with the flight model or something like that. Okay. Anyway, now we'll keep a slightly faster speed. We have flaps 30, landing checklists, engines down, switches. Continuous speed brake, armed landing gear is down, 3 green, flaps 30, green light. Landing check is complete. Yeah, this is really not good. So it happens on all approaches. So I will try to recover before it goes crazy. So like we said earlier, there's something really weird. And the speed looks very strange as well, but it looks correct. So it's not like a unreliable airspeed, but the flight model is just way off, or the weight is not correct, or the weight is not updated, and so yeah, it's really strange. Okay, let's focus now on the landing. Check, land, continue. Although it's non-standard, but yeah, there's nothing else we can do with if it's buggy like this.
50, 30, 20, 10.
I see that we're doing 100 knots and it feels like we're still doing 150, which is super weird. Mind you're braking, but not too hard. Ah yeah, so it is a flight model. Yeah, there's something wrong with the weight. So everything in the like in the visual, everything looks correct for the current weight, but when you fly it, it feels like you are way heavier. So it feels like it's not fully correctly updated. So I don't know. So we're vacating left on Delta. So it's one further, but yeah, there's unfortunately nothing we can do. It's really unflyable. I mean, it's just a simple ILS approach. It's ridiculous. I don't know how you can release an aircraft like that. Now I'll put in this straight line and then I'll do the after landing flow. Come on. And what weather radar off. Okay, now let's focus on the taxi. Oh, thank you very much for sticking with me for quite some time. I have to be honest, I'm quite impressed. I'm actually on time. I was afraid I'm gonna like lose a lot of time explaining or doing the briefing, and well, we managed to keep the within 3 minutes of the departure, so that's pretty good. So now we are on the Echo and left turn on Romeo. So this is the cargo apron, and then we have the passenger terminal to the west. Yeah, so if you have a different approach, um, different minimums based on different approach cam gradient, this is where you have to enter those in the performance tool. I will show you once we get once we are at the gate. Put APU. So that's stand number 5. Seven, and so the next one will be the stand number 8. And here we go, stand number 8. I'm actually quite proud of this 90-degree turn. Spot on. Alright, let's slow it down. And there's no marshaller. Yay. So let's try to read this upside down. Oh, okay, looks like it's a kind of big aircraft parking spot. But it's alright. If they can park here, we can park it. So let's have a look here. That's something like this should be good. And parking brake. Let's have a quick look. Not bad. All right, let's go with the and we are ready for shutdown. Oops, sorry guys. Alright, from top to bottom, left to right. Oh, I forgot again this. they're off. Like, why can't I select those switches? Oh, we still have the EPU, so why not? It's still warm outside, so MCP, let's reset. Alright, this has been reset. Alright, let's do the shutdown checklist. And because this one is right new here, let's open it. Shutdown checklist. Fuel pumps off. Propit as auto. Hydraulic panel set. Flaps up. Parking brake is set. Engine start lever cut off. Weather radar is off. And that's it. That's it, guys. Welcome back to Guadeloupe. I will quickly go with the secure checklist. Oops. Alright, secure checklist. IRSs off. Oops, sorry. Emergency lights off. Window heat off. Packs off. And the shutdown checklist is completed. The next step is the power down. But then this depends on the airline. Sometimes you have engineers that take care of everything. So basically you leave the aircraft, they come in, they do their checks. And they will take care of the shutdown. Sometimes it's up to you to do it as well, so it's no big deal. But on the 7.4 it's like a read and do type of checklist. I think on the 7.3 you can do it yourself. I just request the ground power so I can shut down the APU.